Hello everyone, my name is Krishna and welcome to Rig Electrician YouTube channel. In our last video we learned about encoder basics. In this video we'll be learning about the connections and troubleshooting. We'll be taking some example of old rig data to analyze how good is encoder signal. Let's start with the connection. Here is positive and negative. This is our positive and this is negative. And these are channel A negative, channel B, channel C negative, and shield. This wire is your negative for your reference for the probes for oscilloscope, and it's connected to here. These are two channels, and this is the multimeter side of the oscilloscope which we earlier used, and power up. These are sample settings. You can have one channel or two channel. Here is the selection for to enable the channels. Let's say now our oscilloscope is set for use. Now we already hook up for channel A and channel B. Okay, now we'll see while rotating what's happening in the pulse. You can see that. Look, we pause here and look clearly. This is what a pulse looks like, channel A and channel B. So you can see channel A, between channel A you have 90-degree offset. That's what you're seeing here. So now your encoder is functioning properly. You have your channel A and channel B. What is this? Basically encoder has two channels, A and A negative and P and B negative. Now we'll be looking between. Okay, now we have play again, should rotate. This is what your, now we play again. Okay, look, let me catch up this. Look, this is your A and A negative pulses. This is your A. So what happened? This is your 0 volt, this is your positive volt, this is your 0 volt, this is your negative volt. In one or another, this is your 0 volt and this is your 0 volt. This is your 0 volt and this is your 0 volt. So here he has positive volt, he has negative volt, and here he has 0 volt and he has 0. So what it is doing is switching this 24 volt between one channel to another channel. When let's say channel A positive have, A negative doesn't have, and channel A negative have, A positive doesn't have. So these are called inverted pulse. So one has and another doesn't have. Okay, one will have and another one will doesn't have. Now we will go with some real-time example which I have earlier connected from the rig side. I have some old encoder data which we can use to identify different type of noises. These are like acceptable and non-acceptable level of noise. As you can see here, these are like perfect signal. There is no noise at all. These are just beginning of the noise. Like you can see from the beginning there is a small, and here is a little bigger. You can see the beginning they have, and the end of the pulse have some extra. Okay, these are like double. You can see small noise started at the beginning and these are like no square wave anymore, small noise, but still these are okay pulses. You can use these pulses without an issue. This is getting AC noise. You can see it's like an AC wave passing over the pulses. These are not bad, not good one. Like these are not good at all. These are really problematic pulses. These pulses can overlap and give problem. This is an, you can say, an acceptable level of noise. Thanks for watching our videos. If the videos are helpful for you, please subscribe to the channel. In our next video, we'll be learning more about the noise comparison and troubleshooting with the comparison.